Anything, anybody having any problems? Let me present. I'm not presenting. Do y'all see the whiteboard?
Yes.
Make sure you turn the whiteboard on in your rooms so people can see it, and move the whiteboard over, move my whiteboard over to the whiteboard so everybody can see it. Did anybody have any trouble getting on MyLabs Plus? Everybody doing that okay, or everybody having success with that?
Yes.
Okay.
Yes.
I did speak to somebody. This person was in my 110, and she was having all kinds of trouble. And this is what she finally got on last night. I'm trying to find it because I want to read it to you. Because, well, now I can't find it. It was a Mac. Of course, she couldn't. Now I can't find it. Anyway, she'd been going through like the last 2 or 3 weeks. I mean, last week, trying to get it to work. And there it is. This is what, I'm honestly not sure what I did, but it ended up having to download 9 gigabytes of different software. And then after a bunch of stuff popped up on my computer, one of them ended up being Skype. She was trying to download Skype. And like I say, I've been using Skype in my classes for probably 3 or 4 semesters. And this person just said she just couldn't do it. So I don't understand it. Some of y'all may understand it, but I do know that another one of my students said that the Mac has to have updated Google Chrome, and you have to turn off your pop-up blockers or whatever whenever you're either installing the what is it, Office 365, or you have to, whenever you're doing the MyLabs Plus, you have to do that. So I don't know. Why don't y'all just get PCs, and that way you don't have to worry about stuff like that. Anyway, I'll shut up. Go ahead and look at our first section, which will be probability and statistics. Now, I thought I pulled it up. Where is it? Oh, it's right here. And let's go to the, I think it's 5A, is it not?
Yes.
Okay. So let's go to 5A. And those of you that's had me for 120, you should be looking at your notebooks under Unit 1. Okay? Now, also, how is the printing out of the what is that thing called, the project? Have y'all printed those out yet? Make sure you print them out, because we're going to have to start looking at them. I'm going to have to read them out to you, and you're going to have to start on them. Y'all, I just wish y'all just make up some budgets, and I think you have to make up a budget. I don't know. I got to look at it. But anyway, y'all read over it, and we're going to have to start on that pretty soon, just because I'm just going to do it just so I can say I'm doing it and not be lying, if y'all know what I mean. So anyway, I'll shut up on that. We're going to go through, and I'm going to highlight some things that you're going to be responsible for on the test. And that's pretty much going to be it as far as the reading portion. Like I said, the math portion in Chapter 6 is where predominantly your test is going to come from, where you find the mean, median, mode, range, mid-range, variance, standard deviation. You got to be able to find, and I guess this is just not going to work. It's just not going to pull up for some reason. Let me just go. I'm going to go another route here. Let's go here. Let's go here and 5A. I'll just do it this way. There we go. I don't like to use PowerPoints, but when the book is not working, I'm not going to sit and wait on it. So we're just going to do it this way. Presenter mode, primary monitor, from current slide. There we go. So everybody should be seeing this slide. All right, statistical reading. Make sure you know the difference between uppercase, capitalized statistic, and lowercase statistic. Okay, that's the first thing. Statistics, capital S, is the science of collecting, organizing, and interpreting data. Okay, now if you have your book or if you have your laptop, you can, go through and follow along with it if your book comes up. My book didn't come up, so I don't know what's up with that. Lowercase statistic, and I'll write this right below it because they ain't going to put it right up under each other. I don't know why. I guess that would make sense. Lowercase statistic, the variables used hold on. One of my pens doesn't work very well. Lowercase statistic variables used in formulas for the sample population. And they will be written in terms of alphabetic or the alphabet. The regular alphabet, meaning X bar and S, like the mean and the standard deviation. If you see X bar or S in a presentation, then you know that it's dealing with the sample population. The sample population is always the smaller population. Okay? So, uppercase statistic is the umbrella of mathematics dealing with collecting, organizing, and interpreting data. Lowercase statistic is variables used in formulas for the sample population. Now, let's talk about the population. And I don't know what they're going to do next, but we're going to go ahead and talk about population. Population is the big group. We already talked about sample, but here we go, sample. In statistics, there's two types of populations. There is the population, and then there is the sample. Who would be calling me this morning? I can't.
Good ringtone.
Yeah.
What?
Good ringtone.
Redneck at heart. All right. Population is always your larger group. So a good example of a population would be Tri-County Tech students. All Tri-County Tech students would be like a population.
Priority 1 message coming in on secure
sample is going to be the smaller population that's more controllable. In other words, you can actually survey the smaller population, and that would be, instead of surveying all Tri-County Tech students, I'll just sample the Anderson campus. Now, I just talked about variables used for the sample population are going to be like X bar and S. But for the population, for the big group, they're called parameters. And I want you to write the definition in your notes. How do you write it? Well, you just copy lowercase statistics, and instead of saying for the sample population, you just mark out sample, and then you put Greek alphabet. Greek alphabet. Which is mu and sigma. Actually, lowercase sigma. So copy for parameters, this is what you would put. Variables used in formulas for the population. Greek alphabet, mu, and sigma. So, in general, or in summary, sample population uses statistics in their formula, lowercase, meaning X bar and S. Population formulas use parameters. And those parameters will be Greek letters, mu and sigma. So population, parameter. Sample, lowercase statistic. And of course, the capital statistic right here is the umbrella that statistics that the sample in the population is under. Now, some of y'all have had me for 120. Some of you have had me for 155. This is the same stuff that we did back there in 155 and 120. So if you had me for 120 and you have a notebook for 120, you don't need to write any notes down, because unless you just like writing notes for the second and third time, knock yourself out, because it's the same stuff. Okay? Who's got a question about that so far? So you got three things. You got the uppercase capitalized statistic, which is the umbrella over all of what we're going to go over. And then you've got under that, you've got two populations, the sample and then the population. Now, why do we work with the sample? Because you work with the sample, because if you work with the sample, it involves less of two important things in our lives. And what is that? What is the most important things in our lives?
Time and money.
Thank you. Time and money. Okay? We deal with the sample to predict the population. We predict the population because it saves us time and money to survey 300 people instead of 3,000. Now, I'm going to erase this whole board, so make sure you know, and if you haven't got it, you can watch the video, and you can pause the video, and you can rewrite it, okay? It's not a big deal. All right, I'm going to erase it, and go to the next. Statistics are the data that describes and summarizes something. It's the same thing. I don't know why they didn't just add that to that. Remember, 103, the 103 book really sucks, okay? So you're going to see me disagree with a lot of stuff that it does. Population is the complete set, the big group. That's what I already told you. And the population will use parameters. Now, why do I worry about parameters and lowercase statistic? Meaning, because one of the reasons for this course, as well as the 120 course, is not that you master probability and statistics. That is not the reason for 120, 130, or 103, or Math 155. The reason that we are teaching these three courses and put statistics and probability in it is so you're not ignorant whenever you're in the career world and you see a presentation with statistics. And you see, if I'm giving a presentation and I throw up, you're in a departmental meeting and somebody throws up X bar is equal to 28 years old and mu is equal to 32 years old. So at this point, without raising your hand and looking like a fool, you would say to yourself, okay, they surveyed all these people and they found out that the sample population was, the average age was 28 years old, and the population, the main population, let's say Tri-County Tech, was 32 years old. Okay, that's the average of the population. So here they may have interviewed 300 people. Oops. They may have interviewed 300 people. No coughing in class. And here they predicted using the 300, they predicted for 3,000. Usually this will be a prediction because, well, in this case, you know, with average age, that's pretty easy for a college to get. Why? Because what do you put on your application? You're going to put your birthday, right? Or your age, whatever, and then that goes into a computer as soon as your application is processed. So that's pretty easy, okay? Versus how many people wear blue sandals at home, okay? Or how many people drive a white vehicle, or how many people blah, 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 okay? So usually the mu is going to be a prediction when you're talking about data that we don't know firsthand, like the age on application. Okay? So that's why we're showing you this stuff. And yes, it will lead to going into Math Science 301 at Clemson and going into research statistics and all that. But most of the people say, why do we need to know this? Well, that way when you're in a meeting and you're in a department meeting, a division meeting, and they're throwing up these numbers, you won't go, duh, I don't know what that is. So now you know the difference between a alphabetic variable, which is a lowercase statistic, and a Greek letter, which is a population parameter. That's why you're learning this. Okay? So let me erase that and move on. There's the population parameter. Specific numbers, and I like to say variables because it looks like a variable, okay, because they're letters, okay, describing the characteristics of the population. Sample, lowercase statistics are the same thing. So I just went through and told you what it was in layman's terms. Questions so far? Now again, I'm assuming that there's one or two people in here that have never seen statistics before. I know that I've got about 5 or 6 students that have had me before in either 120 or 155. So I know you've seen this before, so just bear with me. And I know there's people that's had probability and statistics in high school, and hopefully maybe I make something clearer. I don't know. But just bear with me. We'll get to the stuff that you want to get to later that's a little bit more challenging. And I'm not going to do these samples because I'm going to just read them and I'm not going to make a big deal out of it. Describe the population, sample, population parameters, and sample statistic. Agriculture inspectors for Jefferson County measures the level of residue from 3 common pesticides on 25 years of corn from each of the 104 corn-producing farms in the country. Okay? Which one is the bigger number?
104.
So that would be your population because it would be hard to go to each one of those farms. So that means if 104 is the population, what is the sample?
25 ears of corn from each.
Yes, from, oh, well, wait a minute. 3 measures 3 common pests. Okay, let me read it again. Agricultural Jefferson County measures the level of residue from the 3 common pesticides on 25 ears of corn from each. Okay, the sample would be 25, yes, because you're taking a sample from each one. Okay, so you can't do all of the corn on 104, so you're taking a sample. And 25, and I'm just going to go on and show you. There we go. Seek to learn about the population of all ears of corn grown in the county, which is from the 104. So, 25 ears from each of the 100 corn producing counties. Okay, the sample is 25 ears, we said that. And the population parameters of the average level of residue. The sample statistic describes the average level of residues that are actually measured on the corn in the sample. Okay? And the population would be 104 corn producing farms. Okay? And I'm not going to go through all of this. Y'all can look at it. I'm going to leave it on the video so you can read it, because this is kind of like the process, scientific process. Okay? Study, state the goal. Choose a representative sample from the population, collect data, use the sample, draw conclusions. That's just like your your science labs. That's the same thing. I'm not going to spend a lot of time on that. Nope. 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 Good gracious. A representative sample. Nope. Okay, random sample. What is a random sample? This is very important. This is the first things I was going over as far as the sample and the statistic and the population and capital statistic. Those are all standardized test questions. Okay? For you that's going to be taking a placement test in the future, if you're going to be taking a GRE, or you're going to be taking a, what's that thing called for nursing? TEAS test. I think it's TEAS.
Yeah.
Okay?
Yeah.
Any of those. So SAT, ACT, those problems that I wrote, those things that I wrote down, things like that is what I'm going to bring up in the class. A random sample. What is the key words for a random sample? Everyone has the same what? Chance. Write that down. Everyone has the same or equal chance. Anytime you are asked the definition of random sample, that is the definition of a random sample. Everyone has equal chance of being selected. Now, there are some books that disagree, I disagree. Okay, there's a difference between a simple random sample and a random sample. In some books, a simple random sample is a group. Let me explain. Let's say each one of you, I gave you each one a yellow Post-it note. And I told everybody to write on that yellow Post-it note their first name, middle initial, last name in black ink. And I told you to fold it in half and put it in a fishbowl. That would be a random sample, because everybody has equal chance of what? Being selected.
In a piece of paper.
There is no bias in that. No bias. Okay, we're going to talk about bias here in just a minute. No bias. Neutral. Please make sure I spelled that right. Think of a judge or a referee. Unless you're a Clemson fan, then all referees are against you. Okay? A referee or a judge is right down the middle. Okay? There's no bias. It's neutral. If, let's say Miss Jeter, being the rebel that she is, she throws her yellow Post-it note, black ink, and write your first, middle initial, and last and then fold in what? In half. And put it in the punch bowl. Let's say Miss Jeter, she don't like yellow, so she throws her yellow Post-it note away. She reaches in her book bag, and she gets a pink Post-it note, and she writes in green ink, and then she folds it into quarters, and she throws it into punch bowl. Is it still a random sample?
No.
No. Why? Somebody tell me why they think it's not a random sample. Because it's on Post-it note. She wrote in pen. She folded it. She wrote her first name, middle initial, and last name.
It's not the same as the other ones.
Well, how does that change anything? Okay, it's going in the punch bowl, right? What does the punch bowl look like in your brain housing group right now? It's a punch bowl, and it's got all this yellow in it, and then what?
But
One
Okay.
pink
we
one.
have the pink one, so it's
The
the odd one.
person that has to pull that paper out, are they going to see that pink piece of paper? Yes, and as soon as they see it, what happens? It changes. Everything changes. Okay? Just like, let's say they're blindfolded. Well, they're blindfolded, he or she's not going to see the paper. But what's going to happen when they stick their hand in the punch bowl? They're going to feel around, right? They're not going to just go like that. They're going to put their hand in it and mix it up. What are they going to feel?
The texture.
And they're going to feel the different fold. Now, what's going to happen? Now, ask yourself this one question. What's going to happen to that judge? We're going to call the person reaching in the bowl. We're going to call them the judge. What happens when that judge sees that pink piece of paper? Two thoughts. There's either one of two thoughts. What are they? I might grab that piece of paper, or what? I'm going to stay away from that pink piece of paper. Is the judge biased at that point? Yes.
Yes.
Because the pink piece of paper is taking up all the judge's thinking. So you've messed up this random sample by doing something as trivial as writing on a pink piece of paper. Well, what about if the judge feels? What happens when the judge feels that different fold? What is that judge going to think?
His judgment changes.
I'm going to grab it? Yes. I'm either going to grab it or I'm going to what? I'm going to go somewhere else. It don't feel right. So the neutrality has been compromised by sight and feel. So you can't say it's a random sample. Now, a lot of you are saying, good gosh, it's just a Post-it note, or you're missing the whole train and the bus. The whole train and the bus is about this. That is the whole train and the bus. When you're doing anything comparing to probability or statistics, there cannot be any bias. Okay? And that is what you need to remember during the whole semester. Now, the difference between a random sample and a simple random sample in most 98% of your probability books, not dummied down probability books, is the simple random sample, instead of giving you each a piece of paper, I would give these two guys a piece of paper, these three ladies a piece of paper, and this back row a piece of paper, and they would put all of their names on one piece of paper. Then I would give the left side of Easley Campus a piece of paper, and they write their names, and the right side of Easley Campus, and the left side of Pendleton, and the right side of Pendleton. What did I do to the group? What did I do to the population? I broke it up into what?
Section.
Groups, section. So a simple random sample in most books is I take everybody individually and I what? I group them. Okay? Now, in this book, it doesn't tell you that because y'all don't have the intelligence to know the difference between a simple random sample and a random sample. But I'm going to go ahead and tell you right now that there is a difference in most books. A simple random sample is when I group up the population and everybody has the same what? Chance, only there is a group chance. And I put that, and I take those yellow pieces of paper that the 5 groups, let's say 2 groups at Easley, 2 groups at Pendleton, 1, 2, 3. So that's what? The 7 groups. So there'll be 7 pieces of paper in the punch bowl, folded the same way, all yellow pieces of paper, and I pick one. Does everybody have the same chance of being picked?
Yes.
Yes. Only it's in a group setting versus a single or an individual setting. So that's the difference. So let's write that down. Random sample is individually. Individual. Simple random sample is group. Yeah, if Monday, if things don't go right, what's the first thing that's going to happen? The referees are going to get blamed. You wait and see what I tell you. Watch Facebook. Unfortunately, I've got 50,000 people on my Facebook page that are Clemson nuts. So I don't watch Facebook during a Clemson football game. I turn it off. I don't even look at it. Next. Oops, sorry. Let's see what they talk about. Systematic sample. This is the second most accurate. That's why they listed second. The second most accurate. Why? Because it's still random sample. But you may not be picked because they're picking every 7th person in the phone book. Or they pick every 10th person that walks out of the front doors. To survey or to ask a question or to whatever the case may be. Question, gripe, complaint. So that would be your second or third if you count random and simple random as the 2 best. Systematic would be the next best. After that, it's pretty much groups and groups within groups. And then convenience. Convenience is the least accurate. There's the convenience. Let me give you an example of convenience. And if you've had my 120 or my 155, you've heard this before. Let's say I'm a DJ at a rock, 80s rock, because that's the only rock there is besides 60s. Okay? 80s rock radio station. And I'm in a statistics course part-time, and I need to do a survey because I've got to do a project. Okay? Because I go to Tri-County Tech, and I got to write a poster, and I got to do a project. Cutting edge technology here at Tri-County Tech. And I decide, well, heck, I'm just going to use my job, and I'm just going to do this the easy way. So I say, okay, listeners, I'm going to get you to call in right now for the next hour and tell me, do you like rock music? Now that is a convenience sample. Why? Why is it least accurate?
Because not everybody likes rock music.
Well, how do I know everybody likes rock music? How do I know that? Because I work at a rock station and they're calling in. Do you see how convenient sampling can be the most inaccurate? Hopefully you do. Because everybody that's calling me and telling me they like rock music are listening to a what station? Exactly. So a convenience sample, while you may think it can be convenient, may be the most inaccurate. So what you need to write down there is just put convenience sample and put an X through it because you don't want to use it. These are all questions that I would ask on a test. If they give you those things that I skipped, those are not questions I would put on a test. All right? So far, if I've told you to put it in your notebook and I've stayed on this slide more than 10 seconds, that means it could be on my test and it could be on a standardized test. Stratified. We use this method when we are concerned about differences among subgroups or strata with a population. We first identify the subgroups and then draw a simple random sample. A voting precinct, male or female? Voting precinct is a group, right? Democrat, Republican, Independent. That's stratified. Why? Because I have a group and then I have what under that? Subgroup. Let's say I take a survey in this classroom and I busted up male and female. How many groups do I have with me? I've got 3 groups. I've got Pendleton, I've got Easley, and I've got Anderson. I picked one group and then I busted it up into what?
Subgroup.
2 subgroups, male and female. You see what I'm saying? I didn't include all the groups. I just picked one group. I picked Anderson campus, and I busted it up into male and female. That's a stratified sample. Is it accurate? Yes. Is it complicated or busy? Yes. In other words, you have to keep up with what? More stuff. Same thing with the next one, which is probably going to be called, I think they, let's see, they do it in this book. Nope, they don't. Here we go. There's examples. Now I'd like to change this and say, hey, do you have a clean house? That would be an automatic yes. A lot of people saying, well, how do you know? Well, let me ask you a question. First of all, look at the guy. He's all got his shirt tucked in. Look at how neat his shoes are. He's got a leash on his dog. The dog looks like what? What does that tell me about this person? They're naturally neat or sloppy? They're neat. So what do you think their house is going to look like?
Hopefully
Could be
clean.
neat too.
Hopefully.
Another one. Here's another one. Do you have a healthy, H-A-L-T-H-Y, lifestyle? What would you say? Yes. What's he doing? He's walking the dog. He's out, he's doing something. Okay? That's why I always stress that with the convenience sample, because you have to be very careful with the convenience sample. Okay? You have to be very careful. That's why I always tell students, just put an X through it, because most of the time it's the least accurate and it'll get you in trouble as far as statistically. Okay? I could be deplorable and go with this one and tell you what this guy's going to say, but I'm not going to be deplorable or racist or terrorist. I'm not going to do that because I'm already a terrorist and a racist, so I can't.
Yep, you are.
Yep, I am, because I'm a veteran and I'm a NRA card carrying member, and that means I'm a terrorist and a racist. All right, what is that noise? Oh, that means it's time to go. Hey, I'm getting organized here, y'all. Aren't y'all impressed? I turned on my alarm because I'm tired of being late to the 120 class. That's why. So, let's go ahead and cut it off right here. Now, should you be continuing to read chapter 5 and the first part of chapter 6? Yes. I don't want you doing any math yet. I want you to just do vocabulary words. Make sure you write them down. Make sure you do the homework with vocabulary words. I don't want you doing any math yet. So let me go ahead and hit the unrecord button.